Ladies and gentlemen, my name's Paul, and in this RedGamingTech.com video, we're going to be discussing as well as analysing tech news, which as usual has popped up in the past 24 or so hours. Hopefully, you're having an amazing day. We have lots of stuff to get through in this particular video, but the thing that I'd like to start things out with is a patent that I have been sent on Twitter. I didn't get permission to share the individual's name who sent this to me, but thank you very much to him for sending this over. And this patent is particularly interesting because obviously there has been so much discussion of late regarding the feature set of the PS5 GPU, but also how games will take advantage of AI upsampling for the next generation, because as we all know, pixel densities as they increase, they put an increasing load on the GPU. 4K is 4 times the number of pixels as 1080p, and obviously even if you have a ridiculously powerful GPU, you're still asking it to do a ton more stuff. Microsoft have given a lot more details on several features of the Xbox Series X, and one of those is, of course, upsampling, which is using lower precision operations on their GPU, 4 and 8-bit, to basically upsample from a lower resolution. And this technology is really cool because when developers fully leverage it, it drastically reduces the load, which is put on the GPU. Now, this technology, in terms of its implementation, is actually rather different to how Nvidia does things with Turing and also, we assume, Ampere. Turing uses tensor cores, which are basically cores which are really good at running specific mathematic instructions. Basically, the upsampling is not done on the CUDA cores, compute units if you prefer, of the Nvidia GPU. Instead, it's being run specifically on Tensor. Now, with Nvidia, things are a little different as well, because Nvidia uses its own AI neural network to train, and then your GPU does inference. What does this mean? Well, once again, I've gone over this extensively in a DLSS video. I'll link it in the video description. But the gist is that a developer will submit code to Nvidia, and then Nvidia uses its neural network to basically train how to upsample a low resolution image to a high resolution. So it compares a really high resolution image like 16K to the low resolution image, let's say 720p, and each time the 720p image attempts to essentially look like the 16K, it gets a little better, it gets a little better, it gets a little better. And the neural network will go over this thousands, millions of times, depending on the game, until eventually it's able to create a decent facsimile of what you would expect a native image to look like. For example, you could render 720p at 1080p, or you could even do 1080p up to 4K. And it's really cool. As I mentioned, I've gone over this extensively before. With DLSS 1, it was A, not as flexible, and B, much harder to implement, and C, nowhere near as accurate. But with DLSS 2, which really started out with Wolfenstein, and we've seen other games like Control as well be updated for it, honestly, in many instances, you'd hard-pressed to tell the difference between a native image and a AI upsampled image. So I'm not trying to sell you an Nvidia GPU here. What I am trying to do is give you some understanding of how the basic tech works. But with AMD's RDNA 2 architecture, it seems to be a little different. Given what Microsoft have said, and plus as well a couple of patents, we'll get into the Sony thing in just a moment, it seems like these operations run at a lower precision on the standard compute units of the GPUs, on the standard shaders. So that basically means if it's running at a lower precision, you can have more operations running simultaneously. For example, you possibly have heard of Rapid Pack Math, which was on the PS4 Pro, and also was on like the Vega architecture and other GPUs too. What this did is it allowed two 16-bit operations to run simultaneously on the same shader, compared to just one full precision or 32-bit operation, which is obviously pretty damn cool. And with that particular, with Rapid Pat Math, it was used extensively, if memory serves, for checkerboard rendering and stuff like that on the PS4 Pro. Anyway, as I said, I've been giving some background because there has been a new patent which has been discovered, and this particular patent references the PlayStation 5 having machine learning. If you follow along with the channel frequently, you will know that one of my favourite sayings when dealing with patents is a patent is just a patent. A patent does not necessarily equal to becoming a working product. And this is particularly true when dealing with such a complicated device such as a game's console, or indeed pretty much anything to do with graphics in general, honestly, because engineers will research so many different methods of accomplishing a particular goal. When it comes to machine learning, in particular, this is even more true because, well, the field is just so damn complicated. So this patent was actually sent to me by several different people, and I originally recorded this video yesterday, but I wanted to do a little bit more research on this particular topic. So the original patent is in Japanese, and unfortunately I grasp about zero of the Japanese language apart from a few things spoken, so in terms of writing I can't understand it, which means that ironically enough I'm using machine translation, and Google does an okayish job of approximating the wording, but obviously there are some things which are not perhaps 100% accurate with this translation. So it would be amazing if someone who is a native Japanese speaker or has a really good grasp of the language could perhaps do a more accurate translation. But with that said, anyway, there are several interesting things which I find about this particular patent. I won't read out all of it because, quite frankly, it's fairly lengthy, but the technical field is the present invention relates to an information processing device, an information processing method, a program, learned data for generating image representing an object. And it states that in the above technique, even if machine learning is performed using a limited type of images as teacher data, only a reproduced image of pattern relatively close to the limited teacher data can be generated. It's difficult to accurately generate a reproduced image of a pattern that can greatly deviate from the contents of. On the other hand, in order to increase the variations of reproducible images that can be generated, it's necessary to shoot images of various patterns, which is troublesome. And just above that, techniques for automatically generating images by machine learning are being researched as one such attempt, a method of generating an image that reproduces the same target object by using plurality of captured images obtained by shooting a target object, such as a person, as the teacher data. Now notice the phrase teacher data is referenced several times in the sentences that I've just spouted out to you. I believe that this patent is more focused on actually the training part of the equation. Now, a few moments ago on camera I mentioned training and inference. Training is where you're actually, training an algorithm, which is computationally more intensive than the, inference. So, for example, with Nvidia, they use their supercomputers to train data, and then that data can be sent via a small piece of code using drivers, and then the tensicles on the GPU upsample. Similarly, voice recognition and other such things run on your smartphone, either via the cloud, or if it's local to the device, the device is essentially just processing the trained data. It's already been trained, it knows what to do, which is, a lot less computationally expensive. So it seems to be that this particular system is more for actually teaching. And the problem is this ambiguity in how this comes to pass. Now, I'm going to tell you what I mean by that in just a second. Several times this is referencing machine learning and an image acquisition unit. And indeed, it also states that machine learning unit is controlled by a control device, which is basically the CPU. So it seems to me, because if we scroll essentially all the way to the very bottom of this patent, scroll, you can see that there are figures where a camera is being used to essentially take photographs of what looks like an end user, and this is referenced several times in this particular patent. And this does bring me to another patent of Sony, which allows your system to be able to essentially scan your face and even turn it into sometimes a type of emoji. This does remind me in many ways of other patents we've seen from Sony, such as the ability for the system to essentially scan your face and utilize it for things like emojis. Indeed, Sony even have other patents which are for basically, well, I guess the best way of describing it would be having you almost in like some type of virtual stadium, spectating events, using, well, an avatar which basically looks somewhat like you. However, once again, one of the difficulties we're having is that it is in the Japanese language. However, 0044 perhaps also references this perhaps better than others, because it states, and I quote, "By combining the reproduced image with a transparent background with a given background, it is possible to generate an image as if the subject was in another place where this was not actually performed." And this is basically in reference, it seems like, of actually taking the image and being able to put you entirely somewhere different. So I think that this is not necessarily DLSS technology for the console. Instead, I think this is more for user-generated content. With this said, though, it's interesting because this seems to be still processed locally, i.e. on the PS5. I mean, it is possible that this data is uploaded to a cloud server, and then this is processed by one of Sony's supercomputers, but realistically there's a greater likelihood that this is being processed locally, because it also seems to be part and parcel of things like the VR experience. With this all said, I am still fairly certain that a technology which is quite close to how the Xbox handles things is also present in the PlayStation 5 as well. Not only have I had it hinted very heavily that the PS5 does have some type of, let's say, data handling similar to RDNA 2, one of my sources, I'm paraphrasing them, but when I asked them about it, and then I mentioned RDNA 2, they said, well, it would make sense for the PS5 to have this as well, wouldn't it? And they were basically providing me like a leading, let's say, way to do research. I'm somewhat paraphrasing because obviously I don't want to directly quote them for obvious bloody reasons. And also, I am aware that the Italian engineer did state that the PS5 does not have hardware-based machine learning, but I think that it's probably more in the line of something like Arcturus, and whether the PS5 has any of the Arcturus based features, which Arcturus is a GPU architecture specifically designed around machine learning. And I don't think that that's the case. I think that with the PS5, most likely it is more in reference to how Microsoft have accomplished it with the Xbox. Another reason that I believe that this is a process which is occurring locally and also with a camera is I used Google Translate with images, and then basically I simply pointed my phone at the specific diagrams, and you can see here that there's a reference to memory control unit interface, and then in the next image, operation display device and camera. So once again, it seems to me like these are operations which are occurring locally on the PlayStation 5 and also designed around the usage of camera for something like capturing images for a user. Most likely using some machine learning modeling locally on the device. This engineer as well is Italian, so he even admitted that communicating in English was not necessarily his strong point, and he has also gone on record and said that the PS5 GPU is basically RDNA 2, but does have one or two features which differ from the desktop implementation. Of course, I recently put that video out where I detailed much of the PS5's bring up and the fact that the missing features were desktop focused ones. He also, of course, pushed the fact that there are several exclusive features to the PlayStation 5 as well. With that said, it's possible that Microsoft does have a few additional tweaks, especially, for example, the fact that you can convert a game from SDR to HDR. Unfortunately, one of the problems we're having is we don't have a full block diagram and breakdown of how this occurs. To my guess, I think the PS5 still handles things similar to how RDNA 2 for the desktop would function. Basically speaking, it can handle, of course, full precision operations, which are 32-bit, 16-bit operations, which the PS4 Pro can do, rapid packed math, where obviously two operations can run on the same shader because they have precision, and then you also have 8 and 4-bit operations as well, which is what seems, at least according to Microsoft, what they are using for AI upsampling. I don't know if Sony have customized anything for hardware-based machine learning. So I'm guessing it's still not like Nvidia with the Tensor Core. I'll also bring to your attention that Sony in the past have done a lot when it comes to compute. For example, we saw them push the PS4 Pro with, once again, rapid packed math, and before that with the PS4 they were also pushing features such as the synchronous compute engines, a number of compute queues, and also Microsoft and Sony both have access to AMD's internal roadmaps, which go extensively into the past, so they can essentially have a really good idea of what AMD are going to be adding into their system. You may recall my recent video where I was discussing the PS5's APU and GPU bring up, that a lot of these decisions in terms of the design were made like way back in the day, essentially when the PS4 Pro was kind of like just coming out and was like getting feedback from developers, from like dev kits. A lot of that feedback was being incorporated into the PS5, and a lot of the early silicon from the PS5 also dates back to 2018, which is where we started to see their design start to really take shape. I'm also fairly certain that there's going to be a number of patents and tech which both consoles have, which obviously have not become published yet. And I firmly believe that when we finally get hot chips, for example, from Microsoft, we're going to learn a crap ton more stuff. Another factor as well with the PlayStation 5 and machine learning is an interview and exclusive look that Wired had, and this was actually some comments regarding machine learning from Electronic Arts. I could be really specific and talk about experiments with ambient occlusion techniques or examination of ray trace shadows, as according to Laura Miel. Hopefully I've not butchered her name terribly. She, by the way, is the Chief Studio Officer over at EA, but more generally we're seeing the GPU be able to power machine learning for all sorts of really interesting advancements in gameplay and other tools. And she also says that we're making stepping into the generation of immediacy. In mobile games, we expect a game to download in moments and just be a few taps away from jumping in, and we're being able to tackle this in a big way. Once again, this was directly in reference to the PlayStation 5, and of course other developers were singing the praises of things like the SSD and so on. With that said, with this pattern, just to stress, while I do feel that the system itself is capable of AI upsampling using a similar technique to the Xbox, it's possible that this specific patent is either for server-side things, because once again it's not abundantly clear, and also it seems to be from the translation, although once again I am using Google Translate, this is for capturing user-generated content with something like a camera and then basically using machine learning to essentially digitize it. Thanks very much for watching the video. The normal stuff, if you enjoyed it, like, comment as well on the video, and also subscribe to the channel if you've not already done so. And by the way, I'd like to spend a second just to thank everyone who has subbed to the channel recently. It's awesome to see so many new faces. Thanks very much for the support. It is highly appreciated. And also thanks to everyone who has been emailing me, tweeting, and so on as well. It's kind of humbling, actually. I can't really put it any other way. It's just, yeah. So thanks very much to everyone who has messaged me and subscribed and so on. Thank you very much. With all of that said, though, thank you very much for watching the video. Take care of yourselves. Have an amazing day. Bye for now.